in due course. So I have 45 minutes, I think, and I'm going to cover about a day's worth of material. So we'll see how far we get. And the trick to this is, of course, to speak faster and faster and faster and faster and faster until you're out of breath. But I'll try to contain myself. So a brief history of ZFS. Has anyone here not ever heard of ZFS? You might know it as ZFS if you live on the other side of the ocean. Okay, so everyone has heard of ZFS, fantastic. A bit of the history of the file system. It was originally developed at Sun in the early 2000s, about 2001, and was developed for Solaris or Sonos, and it worked really well there. And in 2005, they decided, let's release it as open source. Hooray, open source is great. So they released it as open source, and about 3 years later, it landed in FreeBSD 7, and it was reasonably mature. As of 2019, ZFS still doesn't work reliably on Linux, though I hear that this is improving, which is great. Let me say that I'm actually really happy that we're getting this open ZFS effort going, because competition is good in any market, and having more eyeballs is always good. But FreeBSD has a very mature implementation of ZFS. It's mature in the sense that it's been running on FreeBSD for over 10 years, well, nearly 12 years now. So people have been using it as their root file system on FreeBSD for the past 12 years. It does not eat your data. It does not kernel your files. It's rock solid on FreeBSD. It is also, as you'll see in my demos, it is really, really easy to use on FreeBSD just because it's so well integrated with the operating system. But enough about the history. Let's get into a nutshell of what ZFS does. You've probably heard this several times before, but ZFS provides 4 key things. It provides end-to-end data integrity, which means that it detects silent data corruption at any point in the data pipeline. So from you creating your file to it hitting your block device, and then your block device silently gobbling up your blocks as it runs. ZFS provides pooled storage, so it's a 128-bit file system. That's not very exciting by itself. It just means that the pointers are very long. But as a side effect of this, it eliminates the antique or baroque notion of volumes. When traditional Unix-style file systems, you have to think ahead, you have to predict the future, right? How many files am I going to have 10 years from now, and how much space do I need for them? And you need to predict the future, and you always get it wrong. So volume managers are the bane of anyone's existence who's used computers in the 90s and early 2000s. ZFS just does away with all that. It's both a file system and a volume manager in one, and the file system just grows as you add more storage. Instead of having to, you buy a new disk, you repartition, create volumes, and then you create your file systems. You take away those steps. You just add more disks. ZFS also has a transactional design, which means your data is always consistent. I'm a device driver hacker. My goal is breaking out device drivers. My kernel panics all the time. I write bugs, my kernel panics, and my file system. I can unplug the power at any point in time, and my data. With other Unix-like file systems, if you unplug the power at an inopportune moment, you lose data, and you're spending, half of your life. This is a thing of the past. As a side effect of this reliability, you also get huge performance wins. But transactional means your data are always consistent, and you get huge performance wins. More on that later. And it's very simple administration. I can also use this administrator on many of my machines. I'm a kernel hacker. All I care about is ZFS. It's very simple administration. You can have 2 commands to manage your entire storage configuration. Zip, ZFS to manage your file systems. More on all of that. Let's talk a little bit about integrity. Any of these things can fail. A hard disk's joy in life is eating your data. When you write data to a hard disk, what you are doing is you are feeding the disk. It's a little monster. It just eats your data. Its joy in life is to corrupt your blocks. That's what it's for. Disks have firmware. Firmware has bugs. We know some software. We know some firmware engineers. There might be one of them in the room. Bugs are everywhere. Disk firmware is hideously untrustworthy. Disks are plugged into controllers, SATA controllers, SAS controllers, SCSI controllers. All of this stuff runs firmware. Firmware is written by people like me. It has bugs. That's what we do. The disk controller is going to corrupt your data. The cables rot. Regardless of what they're made of, they rot. After a while, the cables start to corrupt your data. Talked about firmware. Device drivers, the SATA driver, the ATA driver, all of those things, they just corrupt things. Finally, at some point in time, your data is going to live in memory. The memory is also going to get corrupted. So, if you've got ECC memory, it's going to corrupt a little bit slower. But if you have non-ECC memory, it's just, it's going to corrupt. So, what do we do about this? Traditionally, we have disk block checksums, where we store a checksum of the block together with the data block. So if you have a piece of data, we calculate the checksum of this data, and we store it together with the data block. This is all well and good. Unfortunately, if the block is self-consistent, so if the corruption is there before you calculate the checksum will be quite correct, right? It's great, it's wonderful. You have authenticated corrupt data. This is fantastic. So these block checksums, they protect you against bit rot. So if your disk starts lying to you or your cable starts rotting, the disk block checksums will detect that category of error, but there's more errors of that. So bit rot is just one class of things breaking. You have phantom writes, where the disk suddenly decides out of the blue, today is a good day to write a bit, and it goes and writes a bit somewhere where you didn't expect it. Or misdirected reads and writes, where you write to your bit of spinning Rust, you write some blocks, and suddenly you miss, for whatever reason, physics, the cat's kicking your computer. Something happens, so a read or a write is misdirected and a bit falls over. These things happen. A disk block checksum is never going to catch that. DMA parity errors, driver bugs, accidental overwrites, all sorts of things that can go wrong, and your disk block checksum is simply not going to detect that category of failures. So the only thing the disk block checksum does is it will validate media, so it'll protect you against bit rot, essentially. ZFS is a little bit smarter than disk checksum, than block checksums. Instead of putting the checksum with the data block, it puts it in the parent block and it builds a tree. If anyone's ever used Git, this tree structure should be familiar to you. It is exactly the same tree structure that Git uses. It's a self-validating Merkle tree, a hash of hashes, or a tree of hashes that validates. So the entire storage pool is a self-validating Merkle tree, which is it's a very efficient structure for validating tree-structured data. What the ZFS authentication does is it validates your entire I/O path. So in addition to the bit rot, the change checksums can also detect phantom writes, misdirected read and write, parity errors, and even device drivers. Device drivers don't like this. We have to grow up someday. ZFS will keep an eye on your data or the integrity of your data in the background. All of this happens without you having to do anything. Software just does this for you. Now I'm not time. That was integrity. Let's move on to storage architecture. So I mentioned pooled storage. In the past, back in the distant time, we used to have a file system layout or an architecture that looked a little bit like this. You have your disks at the bottom, you have a volume on top of that, and you have a file system on top of that. If you've got a file system on a 1 gigabyte disk, you've got your disk and your file system lives on top of that. That's easy. If you want to go into a little bit more exciting kinds of storage, you would get a stripe or a concat where one disk will have the lower 1 gigabyte of data, the other disk has the upper gigabyte of data. You stick a volume on top of that, and then your file system on top of that. If you want to add a disk, you'll need to add your disk, you'll need to recreate your volume, and then recreate your file system on top of that. If you've got a stripe where you put the even blocks on one disk and the odd blocks on the other disk, again, there's a volume on top of that, and a file system on top of that. And finally, you have a mirror where the left hand of the mirror and the right side of the mirror has a volume on there. Right hand on both of them, but again, your file system is on top of that. The problem with that is that every file system has limited I/O bandwidth. You can only have the bandwidth of one disk at a time, and you have to manually resize your file system. So every time you add disks, you need to go and manually resize them. This is very boring, and the source interactive as you keep adding more disks, your data starts living in more and more places. So accessing certain files might take longer for reasons that become more and more ZFS has something called pooled storage. So you just add a disk, and you have the notion of a pool on top of all those disks. So if you have 20 disks, you have storage pool. It's not one storage pool. Create just one disk disks, the pool keeps growing. You don't even need to think about it. And your file systems, you create them on top of the pool. Is that clear as mud? Yes. ZFS has copy-on-write transactions. I'm just whizzing through these things. Copy-on-write transactions basically means that you cannot ever have your file system in an inconsistent state. So your file system is consistent when you create a file or copy a file or do anything to your file system. You copy-on-write the blocks, then you copy-on-write the indirect blocks, and finally, when all of the other bits of housekeeping have been done, at that point you rewrite your what ZFS calls the Uber block in one atomic operation. So it's at no point in any of these four things ZFS does is your file system inconsistent. So if you're a device driver writer, or you're otherwise fiddling with your kernel underneath, or you are the sort of person who likes to unplug your computer while it's doing things, your file system is going to survive this. You might lose the data you're writing, the newly written data, but your file system is not going to be corrupt. Oh, I heard a scream of terror now. No! So if you unplug your computer before the Uber block's written, you've lost all the bits in the middle, but your file system is not going to be inconsistent when you boot your machine again. It's, don't unplug your computer. But you're not going to lose your file system to unexpected events because of this copy-on-write transaction mechanism. Finally, ZFS has simple administration. So you've got two commands. All of these things, gpart, fdisk, fusk, newfs, mount, etc, fstab, you can throw them away. Nice. I can't remember the last time I ran FSCK. It used to be about a third of the CPU time on my computer went into FSCK. This is all gone. So you have two commands in ZFS. You've got zpool, which you use to add and replace disks, and also to resize pools. On FreeBSD, I think we resize them automatically now. I've not checked. Might be lying. But if it doesn't do it automatically, you just set a flag, and you resize automatically. And then finally, you have the ZFS commands, which you use to do all the things with the file system, like set quotas and reservation, enable compression and deduplication. More on that in a bit, if we have time. Snapshots and clones, and all of the the little grubby Unixy flags on file systems, which we all know and love, like access time and read-only, and all that. So, right, with that said, I am sick of slides. I don't like slides. Let's talk about storage pools. In the real world, when I'm teaching this, I would have you all pull up your laptops with VMware and FreeBSD. But we don't have that luxury here. We have to find a terminal. How do I get my terminal is on the other side of the screen. Hooray. Is everyone young enough to read this? Tell me when to stop. Like there. Hello, the internet. All right, so I have a fresh FreeBSD machine. I installed FreeBSD during the previous talk. I'm very well organized. If you run FreeBSD, you get ZFS by default. In fact, you will find that FreeBSD will install ZFS as your, bigger. All right, Ben says bigger, so bigger. There we go. Screen real estate, good for us. FreeBSD will install ZFS. The installer will use ZFS as its root file system. This is really awesome stuff because one of the things ZFS does really well, which I hope to have time for, is snapshots. Normally, FreeBSD upgrades do not break your machines because we believe in the principle of least astonishment. But if something goes wrong and an upgrade hoses your machine, you can just roll back to the previous snapshot of your root file system and nothing happens. This is a feature I like a lot. We also have boot environments, which I could give an entire other talk about, but I don't have time for. So you should go and look on papers.freebsd.org and find Alan's talk on boot environments, which will change your life. But that all aside, let's say you're guessing that FreeBSD is a friendly, user-friendly Unix-like operating system. Imagine you wanted to create a Z pool of a single disk. Which commands do you think I should type? Z pool, yes? I would like to create one. Yes, this is very difficult. Now it becomes difficult. Yes. Disks. No, the thing needs to have a name, right? Let's give the thing a name. Let's call it tank. Oh, do I have one called tank? No, I don't. How do I list my Z pool? Shocking. These people are so smart. I have no tank yet. Before I do any of this, I think I should go and buy a disk, right? So how do I buy a disk? I walk to the store and I buy a disk. I would like to buy a very big disk. I have gone to the store and I have gone and bought a really big disk. I'm going to, Zpool create. What do you want to call it? We want to call it tank. How do I create this Zpool tank? Consisting of one disk called disk 0. Any guesses? Oh, I lied. I need to actually go to the top. I need to plug my disk in. Type. There we go. I've gone to the shop, I've bought a disk, and I've plugged the disk in. Zpool creates of disk 0. I'll just cheat here and call it. Truncate will create a sparse file of 1 terabyte size, and mdconfig will create a memory device which is backed by this one file. So to create a memory disk, you've now got those 2 commands, but that's not very interesting. We're not here to teach you about memory disks. I'm here to teach you about ZFS. Zpool create tank md0 will create a storage pool. This took a very long time. How do I check whether it worked? Zpool list. Zpool, spell it right. List. Hooray, I now have 2 pools. I have my 1 terabyte tank. Did I actually spell it right? Yes, I did. I have my 1 terabyte tank, and I have my root file system, which is very good. Let's see, go back to my slides for a moment. Storage pools, how do they work? What are they for? Play from current slide. Here we go. So I've created my storage pool. I can just read this screen rather than breaking my neck. And ZFS can use disks directly. So you notice that at no stage did I create a partition table on this disk. I didn't do anything with gparts. I didn't do anything with fdisk, or didn't do any disk labeling. ZFS just uses your disk directly. Here is a disk, use it. I faked it by using a memory disk, but it could just be a real SCSI disk or SATA disk or SAS disk or what have you. MCA disks, remember those? You just, any old disk, ZFS will just use it. There's no money. ZFS is also going to automatically create a file system with the same name. So if you call pool tank, ZFS is going to create a file system called tank on that pool, and it's going to mount it for you. So those are 3 steps which you don't even have to think about. Your storage is immediately available. If I go back to my Xterm here, I can type mount eventually. Hello. I can type mount, and we see that ZFS has mounted /tank for me automatically. So it's gone and created the /tank directory. It's mounted my file system there. I can touch hello on hello. And hello now exists. This is wonderful. I can also delete it because that's so much more fun. Tank. Oops. Hello. I can create and remove files on this fancy new file system. Hooray. My laptop thinks that left is right, so I get confused. Also, you do not need to edit its ZFS will remember where your file systems are mounted for you. And you never need to touch this etcfs tab file ever again in your life. ZFS has a concept. Oops, I'm in the wrong terminal. I use this one. Nicely overlaid. ZFS has a concept of properties which you can set on your file systems. We'll come to that in a bit. If you move your file system mount points to another place in the file system, ZFS will remember this for you, and ZFS will mount your file system where you last mounted it. I think this is useful. Let's go back to the slides. So no needs to edit. Oh, whoa, okay. Now my laptop is very confused. So I should not have done that. Sorry, faffing around. Here we go. So ZFS makes your storage immediately available, and your etcfs tab file, you just don't need to think about that one. Right, displaying pool status, you can type zpool list, as we said. That works really well. You can also type zpool status, which is going to show you, stop looking at my slides, just do it in the terminal. So if you do zpool status tank, it tells you a whole bunch of things. It tells you that the state of the pool is online and it has one disk in it. If you have pools with multiple disks in it, the number of disks will grow. It'll also tell you about errors. So read errors, write errors, and checksum errors. The checksum category is the interesting thing about ZFS. Every file system writes errors. The checksum is something ZFS does for you. In the background, ZFS is doing all these checksums of your files and creating and maintaining its Merkle tree. If any file system or any file walk starts getting corrupt, ZFS will start incrementing the checksum counter there. We'll see that later. ZFS also has a, oops, hello. Focus, he tells himself. There we go. ZFS can also tell you I/O statistics. So you can type ZFS I/O stats, and it'll tell you how busy your disks are. It can also tell you which of your disks are currently being written to and read from, and what bandwidth. I'll just whiz through this because we don't have a lot of time. You can specify the interval, and it'll keep running indefinitely and just update every couple of minutes. So if you're suspecting that your disk is slow, you can just type ZFS zpool IO stat, and it will tell you what the IO going through your disks currently looks like. This is great fun. So we've now created storage pools, we've listed them. How do you think we get rid of them again? This is where we play the guessing game again. I don't want this tank anymore. How do I get rid of it? No, that's too nice. Destroy, zpool, destroy, tank. How long do you think this should take? It's gone. Yes. Destroy is instant. ZFS does not feel that you should waste any time destroying disks. This is a constant time operation. It is not in any way related to the size of your pool. So if you type ZFS destroy, or zpool destroy rather, on a pool containing, your life history, it will take exactly as long as this file system what I just created for this presentation. There are no seatbelts. ZFS is a file system for adults. So just bear this in mind. ZFS has lots of really nice features and lots of really nice snapshots, but if you shoot yourself in the foot, your foot is coming off whether you like it or not. Yes, so constant time operation. Zpool create is also, it's a little bit slower and is in fact related to the size of your pool, but it's not terribly slow. So ZFS is a fast file system, and a lot of the really simple things in ZFS are constant time operations. The simple things are fast, and the not so simple things are reasonably high performance. Let me go back to the slides for a moment. Right, so destroying. Yes, all data on a destroyed pool is irretrievably lost. Of course, you could go and pay a data forensics person fantastic sums of money to go and restore your file system from there, but who wants to do that? Keep backups. Destruction is fast. So far we've just seen a disk or a pool rather, with exactly one disk. That's very nice, but it doesn't provide you with any redundancy. It's just one disk, and it doesn't balance the load across multiple disks because you only have one disk. So ZFS can also work on stripes or concatenated volumes if you like, and ZFS will stripe the data across multiple disks. So out I go to the shop again, and I go out to buy disks inside, actually. 4 terabyte disks. People sell 4 terabyte disks? Let's buy 4 points. Let's buy 3.14. 9 terabyte disks, just because, just That's a bug. Please file a bug. I cannot create disks of high size. Right, great. Imagine, joking aside, imagine I wanted a pool called tank again. That will create a tank, we all got that. Imagine I wanted to have a pool, 1, 2, 3, 4 disks. What would I type here? I would just type the 4 disks, right? Well, actually, I'd plug the disks in first. What did I call up? 1, 2. If I were smart, I would use 4 disks. Not very smart. So we just create. There we go. NP1, NP2, and NP3. Oh no, it's part of an active pool tank. Oh. All right then. Unplug this disk first. Did I create the tank? Online debugging. Oh, so I did. There we go. Destroy tank. There we go. You're gone. Panel. Haha. Hooray. Status. Spell it right. Really spell it right. There we go. I now have a pool with 4 disks, but these are just 4 disks, and ZFS is going to stripe my data across them. That's all very nice, but if any of these disks fails, in any way my whole array is toast. That's not cool. So let's get rid of this again before we accidentally use it for anything. How do we get rid of it? We just destroy it, right? Yep. Imagine I would like to have a little bit of redundancy in my life. What do you think I should do? This is the guessing game. Freebsd is user-friendly. What do you think I would do if I wanted mirrors rather than stripes? Yes, very good. Where should I put the word mirror? There we go. See, this is not very difficult. You've done this course before, haven't you? The point of the guessing game is just to show you that ZFS is actually really easy. Oh no, I only have 15 minutes left and I haven't gotten anywhere. ZFS is going to complain if your disks are different sizes, and it's going to tell you exactly what to do if you want to overwrite that. So I think that's enough about Z pools. Let's go back to the slides and just go through them, because 45 minutes is really not very much time. So stripes are no redundancy, just your I/O bandwidth, and you have slightly higher capacity. Mirrors, RAID 1, you just put the word mirror before the providers, ZFS calls them providers, that will be providing, 1/2 of the mirror each. You can create mirrors of 4 devices, 5 devices, 8 devices, and ZFS will just write to each of those.
Is that identical? So
Yes, you can have 5 identical copies of your data if you have more money than sense. But yes, you can do that. So the mirrored pools provide redundancy, but at the cost of a disk every time. So 5 disks, you get 5 copies of your data, but 5 copies of the receipts for the disk as well. So much more interesting are RAID Z groups, which are a little bit like RAID 5 or RAID 6, which provide parity. So RAID Z1 is roughly the same as RAID 5, where you have one parity disk. So you can lose one disk in your array, and you'll be fine. If you lose 2 disks, you're toast. RAID Z2, if you lose 2 disks, you're toast. So if you lose more than 2 disks, rather, you're toast. Lose 1 disk, everything is fine. Lose 2 disks, everything is still fine. Lose 3 disks, everything is terrible. RAID Z3 is the same thing again. You can have 1 parity disk. I think I have the formula here somewhere. A RAID Z group with n disks of size x with p parity can hold approximately n minus p, blah, and can withstand p disk scaling before integrity is compromised. I'm going to skip ahead to integrity at some points. All of this is not very interesting. Oh yes, increasing pool capacity. Basically, you just keep adding disks. And ZFS will be happy with that. You can turn a single disk pool into a mirror. That's very nice. I encourage everyone to just download these slides and play with this on your laptop. It is really easy, and it is great fun. I'm just going to go to the PowerPoint has a slides index somewhere where I can go to something exciting. Right, so I've talked about pools enough. Let's talk about datasets. Datasets are what ZFS calls file systems, and a dataset is mounted automatically by default. So when you create your storage pool, you do zpool create tank. ZFS will create a file system called tank and mount it for you. If you want another file system, you just type ZFS create. So let's just do that. I think I have my pool. Do I? I do not. Let's just create my pool. Oops, there we go. I now have my pool. How would I create a file system? Any guesses? Zpool create creates a pool. How would I create a ZFS? Not everyone at once. ZFS create, yes. ZFS create, and then I want my file system on the tank pool, and let's call it users just for fun. And ZFS, this constant time. Where do you think this has been mounted? Tank users? Well, let's check that. It has indeed been put on tank users. Great fun. What if I wanted this to be read-only? Any guesses? You're allowed to guess. FreeBSD is nice. Type RO? No. ZFS set. There we go. Let's it's probably an option, so it's probably called read-only. Read-only tank users. Oh no, that's not it. Read-only equals true, maybe? No? Yes. Or it's yes, or I think the minus O needs to go. Read-only must be on or off. See, ZFS is friendly. It tells me these things. There we go. On. What do I need to do to make the file system mounted read-only? Exactly nothing. Right? So if you set a ZFS setting, the file system will automatically be remounted with that setting. If I don't want the access time option, if I don't want my file system to be written to every time I look at a file, I would set A time off, which is the first thing you do on any file system, on any Unix machine. A time off tank users. And if we look at mount again, there we go. A time has been turned off. Hooray! This is easy. Let's go back to my slides for a moment. I have no idea what time it is or how much time I have left, so I'll just 10 minutes. Oh no! So properties. We talked about read-only. We talked about A time. The nice thing about properties on ZFS is ZFS inherits them from its parents. So if you have a whole tree of things, you want things to be read-only, just set the parents to read-only, and everything underneath there is going to be read-only as well. You can, the source of where it gets it from is in the outputs. So if it's inherited, ZFS will tell you this came from a parent. If it's a local property, ZFS will tell you these things. ZFS is going to mount things with the properties it keeps. That's all very nice. Read-only we've talked about. Exec is a useful property. If you don't want to ever execute code on this file system, say, you're not expecting anyone to run code on this file system, just set it as no exec. This is a fun one. User-defined properties. I like this. You can set properties in your own namespace on file system. You can use this for, say, backup features. Your backup tool can write under your own namespace when the last backup was created, and then your monitoring system can complain if that timestamp is too far in the past. You can also keep track of, who the storage needs to be billed to, or where you bought the storage from, and you can just track that in your file system. Whether your file system metadata is the best place to store these things, I would argue, put them in your accounting system instead. But ZFS supports quotas. Very simple. ZFS set quota will give you an upper limit on the number of blocks or number of bytes a user can store. That's easy enough. Play with that in your own time. Reservations are a special kind of quota. ZFS can ensure that there's always enough space available for some user or other. So other file systems, the root file system, or the root user will always have 10% of your volume available. ZFS makes this a bit more generic. ZFS can say, right, I always want to have 500 megabytes available for user Bob, regardless of what anyone else is doing on this file system. That's a useful feature sometimes. Certainly saved me sometimes. ZFS has built-in compression. And again, properties are inherited. So ZFS, you set the compression on your top volume, and every volume underneath does that. The FreeBSD installer by default now sets LZ4 compression on your root file system for you. Compression doesn't only save you space, it also saves you time, because the compressed blocks are transferred from the disk to memory, compressed and then uncompressed, so you have a lot less I/O going on. So your slow disk, this is immensely useful on slow cloud providers. If you run them on UFS, I/O on cloud providers is seriously slow. So if you use ZFS compression, suddenly your I/O speeds go up because there's less I/O. It goes faster. How do you set compression? You just ZFS set compression on, and suddenly it's compressed. For the FreeBSD ports tree, I think with LZ4, I don't think I do the example, but you can win about a third or so, depending on how much data you have. Yesterday or 2 days ago, I was backing up a NUC for a project I'm doing, and it was a file system of 400 gigabytes. It went down to 27 gigabytes, mostly because most of the blocks were zeros, but it just went down to nothing. So that was good. ZFS has snapshots, copy on write snapshots. I really don't have a lot of time. A snapshot is a read-only copy of a data set or a volume. ZFS volumes allow you to run other file systems on top of ZFS should you want to, but you can snapshot them like a ZFS did. Snapshots occupy no space until the original data starts to diverge. So a snapshot is free until you start writing to the original file system. And they are hilariously fast. And you get used to them really my home version on ZFS for 10 years. I delete files with abandon, and then suddenly I find myself on some other file system. I delete files with abandon, and I discover that I can't get them back. ZFS again, it will not save you from using backups, but it'll save you from restoring backups too often. How do you create and list a snapshot? ZFS creates ZFS lists. Apparently I have 5 minutes left, so I should speed up even further. I got about halfway through the slide deck, I should have you know. I'm not going to get to the end of the files. I'll just fast forward to something fun. ZFS has something called self-healing data, which I like to show off in real time, but with 5 minutes left, I can't do it. On a traditional mirrored file system, when you have a corrupt block on a disk, it'll go through the mirror, and the mirror will see the bad block, and the mirror has no idea that the bad block is there. So it passes the bad block up to the file system. The file system, if it's a bad block in a metadata block, the file system will panic, which is good news. That means nothing bad has happened. But the file system can't tell that it's a bad block, so it gives the bad block to the application. The application sees the bad block. This is terrible. Imagine you're an insurance provider and one bit has flipped. someone goes from being, I don't know, someone goes from being 30 years old to being 60 years old, or that's not a one-bit flip. Do the maths in your head. 1 bit flips and someone doubles in age and suddenly, or halves in age and suddenly stops receiving pension benefits, right? So this is terrible. ZFS, on the other hand, has self-healing data. So the ZFS sees the bad block and immediately goes and checks on the other disk. It gives the block from the other disk to the application, the good block, and it goes and fixes the bad block on the original disk. And it tells you, hey, one of your disks is starting to fail. Maybe you should do something about it. Does that make sense? This is great fun. So I do this as a demo. I create, I can probably fit it in 5 minutes. I can't do it because extracting reports will take longer. Ask me during your break. So we'll be very sad if all this data gets lost. So we store some important data. Everything is fine. We've got we've got several gigabytes of data stored here, and then we go and destroy some data by writing dev random to one of the block devices. This is great fun. I destroy one of the disks, and it goes, one of the more devices has experienced an unrecoverable error. Oh no. Applications are unaffected. This is good news. So ZFS tells you that, hey, one of your disks is starting to fail, and this is not a problem for you now. Your application is unaffected. I have detected the problem, and ZFS is now, going around and fixing the file system for me. And with no user interaction at all, your file system may be a little bit slower, but things just move. Everything is okay, everything is fine, and after about a minute, ZFS will say, I have repaired 196 megabytes in 0 hours and 0 minutes. In the real world, of course, this is never going to be 0 hours and 0 minutes, but for this demo, that's all it took. Just for fun, it actually took me a long time to generate this problem. I went and corrupted 2 disks. This is unrecoverable. ZFS will tell you that, hey, applications may be affected, and you'll have to go and restore your backups. Terrible, terrible things. But ZFS is really, really fun. If you add this -v to the output, it will tell you exactly which files have errors in them. Ha-ha, aha, aha. And if I notice that, this FreeBSD disk 1 ISO.xz, I could go and find my backup tapes. Or I could just go and download them from FreeBSD.org. So this is one of the fun features of ZFS. Is if things go terribly wrong, ZFS is still happy to tell you that exactly what went wrong. And I'm out of time, unfortunately, so I ended this on a positive note. This is my favorite slide in the whole presentation. All right. If you would like the other half of this slide, they are all on papers.freebsd.org. If you would like FreeBSD, it is on freebsd.org as well. Talk. I'm going to present in approximately 20 minutes. It is not a 3-day workshop or a 1-day workshop for which I have 45 minutes. So, if you were expecting that, you're in the wrong talk. So this is a talk I originally wrote for the first security track at Apricot last year. It's about improving the FreeBSD security advisory process, which historically has not been known for its greatness. Since I usually present this at conferences where we don't have many people know about FreeBSD, and because this is being recorded for the internet, hello, I should just get the usual terminology out of the way. There are 3 things that are called FreeBSD. The first thing is FreeBSD, the operating system. FreeBSD is a Unix-like open source operating system which is descended from patches that floated around the University of Berkeley way back in the 70s, and it's been maintained by a community of open source developers since the 1990s. So we call that the FreeBSD project. The FreeBSD project is the loose association of hackers from all around the internet who maintain the FreeBSD operating system. Finally, the FreeBSD Foundation is a non-profit organization registered in the US, which is mostly just taking money from people and giving it to the FreeBSD developers, funding developments, funding their travels, and that sort of thing. Who uses FreeBSD? Well, lots of people, probably you. This is a bunch of logos I found on the FreeBSD Foundation website once upon a time, who admits to using FreeBSD. So Apple uses FreeBSD as the base of their Darwin macOS operating system-ish. You know, it's been mangled to within an inch of its life. NetApp, again, mangled to within an inch of its life. People who use FreeBSD more in the way God intended are people like Netflix and WhatsApp, who actually run FreeBSD, the operating system, rather than FreeBSD, the sum of its parts. Sony has, also on the side of Apple and the NetApp, they actually built FreeBSD within an inch of its life, and it runs on various entertainment hardware, let's call it, and all these other companies. So the point I'm trying to make with this slide is that everyone uses FreeBSD. You might just not know about it. Why do these people use FreeBSD? There's a couple of things where FreeBSD excels. One of the things is our community. We are friendly and professional. I'm the friendly side. I don't know about professionals. We have many active contributors and committers for many of those people who've been working on FreeBSD for 10 years, 20 years, and even longer. And our community is very well always very happy to help anyone who uses FreeBSD. You turn up on our mailing lists, and we are happy to help you with whatever adventures you are running FreeBSD on. People like FreeBSD's mentoring processes. When someone comes with a question about FreeBSD, we manage to rope them into the project by mentoring them, and then suddenly they start submitting patches, and they become committers themselves. FreeBSD has fantastic documentation. We are widely known for documenting everything we produce in very detailed ways. We have a handbook, we have a developer's handbook, porter's handbook, and every one of the FreeBSD tools has a man page somewhere. Finally, we have a very friendly 2-clause BSD license, which allows you to take FreeBSD and use it for anything you want, and you don't even have to tell us about it. This is what makes us attractive to some of the larger companies on the previous slides. Unfortunately, where we historically don't really excel is our security track records. We're not very good at handling security vulnerabilities in a timely manner. Sometimes, someone submits a bug report and it appears to languish pretty much indefinitely in the bug tracker. And when this is a security issue, this is not great. Now, there's a couple of things I should mention. FreeBSD has a very large and diverse code base. We've got 4 rough categories. We've got a kernel, but the kernel is not just one piece of software. The kernel has networking in it, has storage in it, device drivers in it, virtual memory in it, and a whole bunch of other things in it. And someone who likes working on the network stack is not necessarily going to be interested in storage or know anything about storage for that matter. Likewise, people who crank out device drivers have no idea how networks work. Once the packet's out of the ring buffer, it is no longer my problem. So there's problems with manpower. People who work on one aspect of the kernel are not necessarily familiar with other aspects of the kernel. Likewise, userland. Kernel developers might not know much about userland, but they're interested in it. And even within userland, there's different bits and pieces of moving parts of FreeBSD and different people running it. And then we've got third-party components which we have inside FreeBSD. We ship OpenSSL, we ship OpenSSH, send failout back, NTD. All of these things, that's just a subset of what we ship with FreeBSD, but all of these things have a more or less dubious security track record. And when they break in FreeBSD, it's FreeBSD security team's problem to make sure that they get patched in a timely manner. And last but not least, reports collection or packages collection. I think it's more than 38,000 third-party applications now. Any of those things might have security holes. a ports developer or a maintainer of one specific port, you might not know about any other thing. So we have 400 or so FreeBSD committers, I think at last count, but they all work on different things, and our code base is large and diverse. So even if one developer has time on his hands to keep an eye on security issues, they might not actually be familiar with the issue that is currently a problem. So how does a vulnerability response work? Well, if it's a FreeBSD problem, so hello, I have found a buffer overflow in part of FreeBSD. Only FreeBSD, then there's no NDA, there's no explicit embargo. It only applies to FreeBSD. It might also apply to NetBSD, and there's no major risk of exposure. So that's one category of problems we have. And this one is comparatively trivial, right? It's just a FreeBSD problem. We just patch it, we send a security advisory, and we're done. The only problem is that, someone needs to have time to work on this. A more complicated category of problems is the multi-vendor coordinated response. This is, recently has been a very popular category of bugs with speculative execution problems. When they tell us about it. When? If they tell us about it. And who are these us you talk about? FreeBSD is an open source community. There is no us, so we'll come to that. This is much more complicated. So there tend to be non-disclosure agreements or explicit embargo deadlines, and you can't just share this information with everyone. The response needs to be coordinated via either a private party, usually whoever discovered the bug, which sometimes they're individuals, more usually they work for vulnerability research firms, or they're coordinated by some certs or it requires limited disclosure to containment information, so it's really deeply embarrassing if some FreeBSD individual knew about a very impactful bug and shared it with the rest of the internet on Twitter weeks before every other operating system known to man has been patched. So we have to be a bit careful about that. So examples of that are all the speculative execution bugs. This is a slide deck from 2018. 2019 was also rife with that sort of. So we have two classes of vulnerabilities. FreeBSD only response, comparatively trivial. Someone sends us a message to the security officer list, which is a small group of people, and we fix it, we send the security advisory, done. Multi-vendor coordinated response, much more complicated. We get an email from either the researcher who's discovered the bug, or from a cert CC, and then the whole dance starts with non-disclosure agreements or explicit embargoes, and it takes a lot longer. You can't just go quiet halfway through. So who deals with this on FreeBSD? Well, we have a security officer, and the security officer has a very broad charter and needs to do a lot of things. This is a lot of words on this slide, but we need to resolve disputes involving security. If someone introduces a security bug that unfortunately leads to some disputes from time to time, and the security officer tends to get wrapped up in that, and you end up with long email discussions which are no fun for anyone. We also have to resolve software bugs that affect the security in FreeBSD in a timely fashion. So all security bugs are the security officer's responsibility. Great. Then you have the bureaucracy part. We need to issue security advisory to FreeBSD. It's a fairly involved process. We have to create the patch, work on all the branches, commit the patch, get the commit numbers, and then write the advisory and send the advisory out to the announcement. There's a couple of steps involved. Many of them have been automated by shell scripts, but there's still quite a few of them that require we have to reply to vendor inquiries regarding security issues. We have a bunch of people, well, a large bunch of people incorporate either FreeBSD as a whole or the sum of its parts, or more or fewer of the parts of FreeBSD. They will have questions about like them in a timely manner, or they will think that FreeBSD is dead or FreeBSD is dying, and those sorts of things. for them, it's not great for us either. The FreeBSD security officer is also expected to audit as much code as possible. This is a lot of work. And we need to monitor the appropriate channels for bugs. So we need to keep our eyes open on Twitter, which is increasingly where bugs are reported. I'm not sure how that works. And we need to participate in architecture. New bits, then we should make sure that they don't deteriorate the security of the operator. And finally, we need to maintain security officer PGP. This is the easiest part. Just don't leak the PGP key. So what are the challenges of this? Well, it's an extremely broad mandate. That was a lot of words on a slide, and it's a lot of hurry up and wait. This is the problem with security bugs. It's very quiet for a couple of months at a time, and then suddenly everything catches fire. Nothing is happening. We're just working, and you know, we have all these other background tasks, right? So it's not as if we're bored. So nothing is on fire. We're just monitoring code. We can be keeping an eye on the bug tracker, and security work doesn't happen. But then suddenly everything catches fire, and people have other things going on. People have day jobs, families, lives. I understand, and some of these bugs require a very high level of technical knowledge, very specific to something that breaks. The speculative execution bugs are a good example of this. The number of people who are familiar with the deep innards of the Intel architecture, which broke, are few and far between, and they need to have time. And this leads to, well, inevitable, it leads to burnout. So we've gone through a number of security officers in a short period of time, and the hurry up and wait bits is just not conducive to a friendly working environment. And there's very few people who have the level of knowledge required to do the job. So for one thing, you need to be familiar with the security process. What sort of response is expected from a security team? How do NDAs work? How do embargoes work? And then you need to also know the moving parts of this FreeBSD security process. But then if you want to actually fix the bugs, you also need to have domain-specific knowledge. And this is very difficult to find qualified candidates. So the FreeBSD project is fixing this a little bit. This is an ongoing process, but we've put some new, fresh blood in the security team. We have a new security officer, Gordon, who is not burned out yet. Hang in there, Gordon. We've split up the technical resource requirements from the vulnerability response requirements. So historically, the FreeBSD security team was a mailing list with a sympathy of 1,000. It wasn't ever 1,000 people, but there were 20 people on a mailing list, more or less active, with lots of domain-specific knowledge and some bureaucratic knowledge. And vulnerabilities were just handled, or vulnerability reports rather, were just handled on an as-needed basis. And inevitably, quite a few of them just slipped through the cracks. That wasn't sustainable. So we've changed our way of working so that we have a smaller number of people on the security officer alias who are mostly delegating the work to other people. This allows us to use our non-technical resources for vulnerability response. So I've put on the secretary hat for my sins, and all I do is I reply to people and I make sure that bugs are tracked. We have a bug tracker. We make sure that people who report bugs are actually kept in the loop, and we delegate the actual research and fixing of the vulnerability to people with domain-specific knowledge. So we just assign the bug to them, or we rope them in other ways. And that's been working really well now. The FreeBSD Foundation, remember my 3 FreeBSD things, are also helping improve the FreeBSD security track record or security vulnerability handling. The FreeBSD Foundation can sign NDAs, which is really helpful. So, large vendors of CPUs, which seem to break with alarming regularity, find it a lot easier to share exactly how broken they are with an organization with which they've got an NDA, rather than a loose band of individuals who might go off on Twitter and share the dirty laundry. The FreeBSD Foundation also has money. I'm not allowed to say that, but I'm saying it anyway. The FreeBSD Foundation has some amount of money and can pay for some things. So the FreeBSD Foundation pays for the deputy security officer's time. Ed Masters, I think, full-time employee of the Freebsd Foundation. He's being paid as part of his duties to work on security. Great. The Freebsd Foundation also pays for the security officers' travel to certain conferences where other security people meet. And the Freebsd Foundation can pay for development resources to enable response. So we've got one full-time employee, Caustic, who is just cranking out fixes to all sorts of bugs all the time. And this is immensely helpful to keep FreeBSD secure. And as a case study, this is a slightly stale one. It's the slide deck is from 2018. The debug register vulnerability in the Intel CPU, where debug registers were, not behaving quite the way we thought anyone thought they were specified. It was a multi-vendor response, and FreeBSD was pulled in early because we could. The right people at Microsoft knew who to talk to at FreeBSD. We had representation from all BSDs, Microsoft, Apple, Citrix, VMware, a whole bunch of Linux distributions, Google and Intel. There was lots of collaborations on proofs of concepts with other variants of BSD. It turns out that the fix was similar to all of the BSD variants. And once the cert was involved, we could also give patches to pfSense, which is a FreeBSD distribution which runs on firewalls. We managed to publish the security advisory within an hour of the embargo being dropped, and we managed to be there before Red Hat, which makes us very happy. So, historically, FreeBSD has not been particularly good about being on top of security, but we're improving gradually. I like to improve faster, but things are actually moving in the FreeBSD community. And that is the end of this talk. Any questions? Hello. There is a microphone for the benefit of the internet. It might even work.
Sorry if I missed the first part due to a phone call, but does FreeBSD have a formal process for notifying of vulnerabilities and aberration?
Yes, we have the security officer address is the formal process. We publish a PGP key. So the formal process is you send a message, you send an email, you are a security researcher, or you are a representative of a large tip company, or you are an individual who has found a bug. If you are any of them, you send an email to the security officer alias. You can set that encrypted with PGP if you like, and you will very quickly wake up and see that email. Usually, I manage to respond to the security officer mail within about 20 hours. And then I copy-paste the emails into the security tracker. The security team now has fortnightly calls where we follow up whatever's in the bug reporter. Anything that's critical will probably be dealt with earlier. If it's lower priority or less important, it might take a fortnight or so before anyone actively looks at it. But if it's something like everything is on fire, it'll usually get someone's attention within a day or two. Well, within a day, ideally, probably within a day or two, anywhere on Earth. But yes, mail to FreeBSD security officer does not go into the void. It never actually did go into the void, but it could appear that it was not being looked at because there was no one responding. So it happened in the past that someone reports a security bug, it gets fixed, and eventually a security advisory goes out. But at no point did anyone think of replying to the submitter. This is no longer the case. Any other questions? Yes, the microphone is somewhere in the back for the benefit of the internet.
Out of all the reports you get, what's the signal to noise ratio? So maybe a number in how many?
I don't have exact numbers, but not great. So we get a lot of, and I don't think there's any security people from other operating systems around, but I've given this talk at security conferences before, and it's about average for the industry. So we get a lot of email from what I would call vulnerability trolls, who just go and fuzz parts of the operating system, and then if you are root and you load your gun this way, point it at your foot, and pull the trigger, your foot falls off. If you are root, if you already need privilege in order to exploit this bug, it is not a security vulnerability. It's a bug. It needs to be fixed, but the security officer list is not the way to go through this. So we get a lot of bugs that smell like security bugs, but are not actually security bugs. I don't have exact numbers, but a large percentage of the email we get to security officer is of that variety. I have been playing with the system, and I'm running as root, and I'm doing something the system does not expect, and this is a security vulnerability because my kernel panics. No, it isn't, because you are running as root. So we get lots of that. So the signal-to-noise ratio is not great. We also get a lot of spam, but yes.
Alyx?
I'm also postmaster for my other sins. So yes, the security officer alias is also spam filtered, but there's a non-spam filtered version of the security officer address, which changes every now and again and is published on the web page. So if you suspect that you have sent a message and it was caught by the spam filter, or the spam filter has told you that this message was not delivered, then there is another address which rotates every now and again, which has no spam filtering and gets a lot of spam. So yes, the signal-to-noise ratio, not great, but not actually terrible either. Any other questions? No. Oh, more. Hooray.
You mentioned that you follow Twitter looking for...
I don't. I don't. We are expected to, I think is the wording I used. Monitoring the appropriate channels, yes, that's what we are expected to do. Some people do, actually. Ed is really good at following Twitter, and if something comes up, and we do have every now and again someone else who monitors. The nice thing about social media is other people follow it for you. And every now and again we get 3 or 4 emails from someone who saw some Twittergram with everything is terrible, and happily in the majority of those cases it's of the variety, I'm running as root and I have shot myself in the foot, and I think this is a security problem, but every now and again it isn't. Yes. Oh, Andy again, hello.
How well do you collaborate with the other BSDs? So Net, Open.
We have a good working relationship with them. So if there's a bug that affects the other BSDs, we know the right people to talk to, and we can collaborate closely. So I don't have an example at the top of my head, but bugs that affect only the BSDs are actually a lot easier to deal with than bugs that also affect other operating systems, because we share conferences, we have faces to map to names, we know when people are awake, and we know also roughly who is working on which part of the other BSD's kernels, so we can immediately talk to the right technical resources in addition to their security people. So
when you're working on a bug fix, say on FreeBSD, to the OpenBSD and say, hey, have you...
If it affects them, then we would reach out to them, yes. I don't have an example at the top of my head where we had to talk to OpenBSD because our kernels diverge, or our operating systems diverge quite a bit. And actually, when it comes to OpenBSD, it's probably more likely that the collaboration would be in the other direction, because we are a consumer of things like OpenSSH, which, OpenSSH has a very good security track record. But if something like OpenSSH were to spring a leak, we would expect the OpenBSD folks to get in touch with us. But when it comes to the speculative execution bugs, we know the right people to talk to. Unfortunately, the big ones are not under our control, because we are, there's the multi-vendor thing. We might have an NDA with, say, Intel when Intel breaks, but we cannot share it with OpenBSD because they are not us. So when we can share with the other BSDs, obviously we can. So that's the left side. The FreeBSD only response is actually, there's two classes of that. If it's only FreeBSD and maybe NetBSD and OpenBSD, then we can quietly sort it out among the BSDs. But when it's multi-vendor coordinated response, then we need to stick to the terms of the embargo. We need to stick to the terms of the NDA. We can't just, we will consider NetBSD as part of FreeBSD, or we'll consider OpenBSD as part of FreeBSD for the purpose of this vulnerability. It doesn't work that way.
The other fun part is that while the BSDs have a common ancestry, that ancestry was a long time ago.
Yes.
And so NetBSD and OpenBSD internally in the kernel are quite different to FreeBSD. And OpenBSD has even drifted away from NetBSD somewhat, but less so. Yeah. And so when it comes to things like speculative execution, that involves a whole lot of work inside the virtual memory subsystem, and that is hilariously different between FreeBSD and the other two. And so while it was, it would be nice if that was easier to deal with, it's not.
But there are other things where we share codes. So
OpenSSH is a perfectly good example.
And any codes that existed before the NetBSD FreeBSD split is very easy to deal with. But very little of that code is still, quite a bit of that code is still relevant, but not very much of that code is still security sensitive. So if someone breaks Telnet, actually, about a year or so ago, someone found a bug in a Telnet client. So if you, if you talk to a rogue Telnet server, one of the Telnet control signals could make your Telnet clients be upset. And if you run Telnet as roots, obviously, bad things can happen. And we happened to share that code with the other BSDs, and we had a nice discussion about it. And I think we all released patches around the same time. And any code that's from later than the mid-90s is going to start diverging, and any code from the mid-2000s onwards is diverged wildly. So as far as the kernel is concerned, there's not much overlap anymore. User space, of course, is a different kettle of fish. And unfortunately, the multi-vendor, we would like to be closer friends with the other BSDs. We happen to like them. But when it comes to multi-vendor coordinated response, it's not us coordinating. It's whatever cert is coordinating it that gets to call the shots. And that does unfortunately lead to some, let's say, interesting presentations at other conferences where, yes.
Mention the war.
Don't mention the war. It was a long time ago.
You may have answered this, but I missed it if you did. How many people in the security team for FreeBSD?
Baker's dozen, a handful, one of those numbers.
And is there more than one security officer, or is that a single?
There's one security officer. Gordon's the security officer. Ed is the deputy security officer. There's at least 3 people with the PGP key, and 2 of those are known to be able to use the PGP key. I think, yes. There's something about a passphrase that comes up every now and again. But
so then the other 9 or so people, whatever
yes,
it's
yes.
are just sort of supporting.
Yes, a small, yes, exactly. And we have fortnightly calls, and it's usually about 6 of us, 5 or 6 of us on the call. And it is extremely difficult to organize conference calls on more than 3 continents at a time. But and I always draw the short straw. It's always crazy o'clock in the morning or crazy o'clock at night for me. I don't sleep. Sleep happens to other people. Yes.
Some of the very big and very profitable logos at the start of the presentation are presumably quite reliant on FreeBSD to be secure and trustworthy.
Yes.
Are they terribly good at financing these sort of paid security positions? Or follow-up question, should they be?
Many of the big logos on that slide give money to the FreeBSD Foundation. And the point of the FreeBSD Foundation is to fund FreeBSD. Well, one of the points of the FreeBSD Foundation is to fund FreeBSD development. So indirectly, Yes, many of the logos on that slide do contribute to the FreeBSD security process. Additionally, we also have a reasonably good working relationship with many of the logos on that page, where if they find a vulnerability in their derivative of FreeBSD or in their use of FreeBSD, as the case may be, they do send email to us and let us know, so that we can share a CV or we can at least coordinate response. That's not to say that there's no room for improvement. There's always room for improvement. And with some of the bigger names, that does require bureaucracy, and the FreeBSD Foundation is a useful vehicle for that. I don't know how many of those large logos, Deb, do you know how many of those large logos we have NDAs with? At least one of them. Yeah. So, yes. So we do have reasonable coverage there. So if and those tend to be the ones that require the multi-vendor responses, which are really time-consuming and sometimes frustrating. But I think that security is frustrating. All right. I think I have consumed more time with this talk than I was allotted. Ooh, is that allowed? All right. I think we call that the end. Thank you very much.
Okay, it's 11:40, so I think we're due to start. So my name is Ben Woods. I'm going to be presenting an introduction to FreeBSD ports. And I noticed when I was starting to prepare this slide that it was 25 years since ports were originally created. So there will be a little bit of history in there as well. Yes, that QR code does actually work even with the logo in the middle. I was surprised by that myself. So a little bit about me. I'm a FreeBSD ports committer. I've only been a committer since 2016, so I'm pretty new to this myself. So there are much more experienced ports committers out there. So I'm almost like junior in the community, if you like. I maintain 59 ports at the moment. I think that grew to 60 the other day, and I've done about 440 commits to the ports tree, and that's to the head branch. Why did I get involved? I was using FreeBSD and I wanted some programs improved, and so I just started contributing patches, and before you know it, I was punished with a commit bit. A little bit about that later. But this is just a hobby for me. I use FreeBSD at home for all of my machines. It's not related to my day job. I work in oil and gas. I'm an instrument controls engineer, and despite a few efforts, I have been unable to link my hobby with my personal job to date. But before I progress, I just wanted to get a show of hands in the room. Who's used FreeBSD ports? Okay, that's 2/3. Another show of hands. Who knows how they work under the hood? Well, that's a few less hands, a couple. Okay, so hopefully you'll get that out of today's talk. So a little bit of an agenda. What are ports? How you're supposed to use them, how they work under the hood. If you want to start developing ports, how to do that, and then also what the process is like to become a FreeBSD ports committer. And a little bit on Poudre if we have time. I've got a pretty action-packed agenda, so we may run out of time for that. We'll see how we go. So, first of all, what are ports? Right, so you've just finished installing your shiny new FreeBSD install. You've logged in as root. You've got a nice terminal there. Now what? So you try and run some commands that you might want. You might want to start an X session, run Firefox, run GIMP, anything. You can see a list of commands there. You're going to get a command not found. FreeBSD does have a lot of fantastic tools in base, but it doesn't have a graphical desktop, for example, and there's a lot of things that you're going to want. So to make almost any FreeBSD installation useful, you're going to turn to ports. So ports, the FreeBSD App Store before the term was claimed as a trademark. I think Apple's venture into that was actually declined by the courts, but they tried to trademark the term App Store. So what are ports? They're essentially formulas that simplify installing third-party packages. And these formulas include all the typical steps to download and install software on a FreeBSD machine. So that includes giving you the option to configure build time options for any program, but it'll go and download the program from the developer's website. It'll extract it onto your file system, apply any local patches. It'll run through a configure step and then actually do the compile, and then it'll stage the installation, package it up, and then finally install it on your machine. So it's a little bit different to how you would install packages on Windows. Normally on Windows, if you want to install Firefox, you're going to be browsing to mozilla.org. But like on Linux, when you want to install Firefox, it's all done for you. So you don't have to go to the upstream developer's website. You just type package install Firefox, and it knows how to do that. The bonus of FreeBSD ports is that it provides a really consistent way to install any application. I know if I install a port, I'm going to find it under /user/local and probably /bin underneath that. And the user experience is consistent across any program. If you're going to start a service, it's going to install an rc.d script for you, and that's often done by the FreeBSD ports team to make it so it's really nice and easy. So who makes these apps? Well, the ports team don't actually develop all these 30,000 something programs. That's done by the upstream developers, yay for open source. What we're doing is we're making sure those programs work on FreeBSD and providing the formula to download and install those programs. Often these days that requires local modifications to the programs because more and more programs these days are being written with Linux in mind and using Linux kernel calls or Linux userland tools that aren't sort of part of POSIX. And so we have to patch the program to translate that Linuxism into the way you would do that on FreeBSD. So, a little bit of history. Ports is now celebrating its 25th anniversary. Well, it did last year. Ports were created by Jordan Hubbard. He was one of the original FreeBSD founders. In 1994, he committed the first ports framework, and in 1993, he committed the package install tools that was used to install packages. That's subsequently been deprecated by the new package system. There is a good Wikipedia page on ports history there. I reached out to Jordan Hubbard last week and got a quote from him for this presentation, and I'll just read through it, so bear with me. So the ports collection arose out of nothing more significant than sheer laziness on my part. I was installing a lot of FreeBSD machines from scratch in those days, particularly as I was provisioning a lot of new servers to deal with our growth. And I got really tired of grabbing source tarballs from various FTP sites, unpacking them, applying any necessary patches, and then configuring, building, and installing them. It's hard to remember this now, but in the days before pretty much everything you was packaged in binary form, you had to build everything from source. There was no recipe for doing this, you just did it by hand using memory, tribal knowledge about what configuration flags to use and environment variables to set. That's quote 1 of 5, so stick with me. All of this was incredibly labor intensive and I was already something of a ninja at using make, having written at least one version of make myself in the same decade, so I decided to use BSD's make robust macro mechanism to see if I could generalize and automate all of the work I was doing. From the initial idea to the first proof of concept implementation, it was 24 hours, which I think is pretty amazing. He got the first few ports done the next day and then went back and refactored the macro files, went through some more iterations before committing the first version of the macros as well as my reference ports. There's a link there to the first 70 ports. Once we got 300 ports or so, I managed to hand responsibility for the whole thing to Satoshi Asamai, I hope I'm pronouncing that correctly, who was the first portmaster and responsible for truly refining and scaling ports collection up significantly, as well as recruiting the first group of ports committers. The project owes Satoshi and the initial ports committers a significant debt of gratitude for really taking it to the next level. I can't believe there are over 32,000 ports today. I think it's amazing that he managed to start something up and then hand it off very quickly. That's anyone in open source knows that's a skill. Some fun facts and not so fun facts. Jordan wrote the package management tools and started publishing binary packages before he wrote the ports collection, which baffles the mind. I don't really know how that works. So I had to later go to a considerable amount of work to make the two systems work together. With the benefit of hindsight, I would have done ports first and packages second, yielding a better architecture, but we eventually fixed that. The next quote is a little bit of an insight into Jordan and his personal life. He lives with 14 cats and 7 dogs, so I've replaced software husbandry with animal husbandry, though the pets are a lot cuter than a lot of software I've seen over the days. All right, enough history. I thought I'd cover a little bit of similar frameworks to FreeBSD ports. So as I said, FreeBSD ports came in, was it 1993, 1994, I can't really remember. And so Debian created their depackage tool at around the same time. NetBSD got package source a few years later. Red Hat's RPM tool came in around that same time. Another year later, Debian created the apt tool that you've probably come to know and love. Yum was created a year after that. And Arch Linux created Pacman in 2002. The reason I bring that up is because it's kind of similar in a way to FreeBSD ports. The other ones are a little bit different, but Arch Linux was quite heavily inspired, I think, by FreeBSD. And in the same year, Gentoo's Portage came out, and that was also directly inspired by FreeBSD, and you can see a quote there. Most of all, I was impressed with the FreeBSD port system. This is from the Gentoo developer. The technology used to maintain and upgrade the system. Unlike the Linux approach, ports didn't use binary packages, but instead automatically compiled everything locally from their original sources. I'm pleased to say today you no longer have to do that. You can if you choose, but package install Firefox works just fine, so you don't have to do it from source. And then the other thing that Arch Linux has done, which I quite like and wouldn't mind introducing to BSD at some point, is the Arch user repository. And I guess the point here is that you can't just commit, any old person can't just commit new packages to the Arch Linux repository. You have to be a known element in the community and be given those privileges. But you can just go and create an account on the Arch user repository and just go start committing things. And then if you're using Arch Linux, you can pull packages from the Arch user repository. So it's a really interesting idea. I mean, I guess if it's broken as an end user, you kind of use it at your own. You know, there's no guarantees of the Arch user repository, but it's a nice way to get users and new developers into a community. So maybe it's a good idea for BSD at some point. Right. So what's in FreeBSD base? So I guess what's all this talk about FreeBSD ports when you've got a FreeBSD base operating system? We keep on saying FreeBSD is a complete operating system. What does that mean? So you've got your kernel and your device drivers, your man pages, and all your userland utilities that come with FreeBSD. So those are things like your ls commands, find, you have VI text editors. Note that Emacs doesn't come with BSD. And then you've got system administration and networking tools like ifconfig, netstat, route. They're all part of the FreeBSD base. You have some virtualization and container tools like Beehive and Jails. Even OpenSSH is built in, both the client and the server. You can fetch things. OpenSSL is built in. There's a bunch of developer tools, CC, make. So there's a huge amount of stuff you can do with a base FreeBSD install. So what do we need ports for? Well, in ports, you'll find, and the number is now 38,290 different programs, so it's growing pretty rapidly. If you want a graphical desktop environment, KDE, GNOME, XFCE, you're going to be turning to ports. If you want a web browser, you're going to be turning to ports. If you want office tools, ports. Graphics tools, audio, video tools, chat, web servers, mail servers, databases, developer tools and languages, configuration management tools like Ansible, Puppet, they're all in ports. So that's what you need ports for. So, I keep on talking about the number of ports growing. This is a timeline provided by freshports.org of the number of ports in the tree. So you can see it when they started recording in 2003 or so. That's obviously not when ports started. It's just when FreshPorts started. It was at around the sort of 7,500 range there, and it's pretty consistent growth. If anything, it seems to be speeding up lately. So it's really not plateauing. And all of that means we need more ports developers because maintaining 38,000 programs is tough. Right, so next section, how to use ports. My advice is don't use ports. You're not really supposed to use ports today to maintain packages on your system. The days of building packages from source and installing them, for me, I would not recommend that to anyone. Even if you want to customize your programs to have a different compile time option, I would say don't use ports to do that directly. What you should do is use package. And so don't use ports for installing programs in your machine. Use package for that. Don't combine ports and packages. Why am I saying this? Using ports directly does work in some simple cases, and a lot of people still do it, and that's almost a bit of a frustration in the ports developer community that people are still using ports directly. The big issue with that is the output of a port build varies depending on what other programs you have installed on your machine. So if you're doing a make on your machine? Or do you already have some Python scripts installed on your machine, and that's going to see them and pull them in as dependencies? So you really don't have a clean build environment. This results in bugs, and when port maintainers are trying to troubleshoot those bugs, we're like, works for me, I can't replicate your problem. So if you are going to be building ports, you should be doing so in a clean environment. Do use ports for building packages in a clean environment should you choose to. There's a really nice tool called Poudriere for that. I'll talk a bit about that later. And then use these package management tools to install the programs that you've built from ports. The FreeBSD project does do this for you, so you don't need to build ports. FreeBSD provides a whole bunch of infrastructure which is continuously busy building ports. So you only need to do it if you want to customize the packages and the build options. So what is this difference between ports and packages? So ports are those formulas for how to download, build, and install a program. Typically, this means compiling from source, which is time-consuming, and it will download the program from the upstream developer's code repo. I'll keep using this term upstream. What I mean by that is, Mozilla.org for Firefox is upstream, whereas the ports is downstream. So packages are the pre-compiled binaries which are ready for you to install. They're generated using the formulas from ports. And when you download packages, you're not downloading them from the upstream developer's website, you're downloading from the FreeBSD package repo. So these are available in the FreeBSD package repo, and they're updated every few days. And you can make your own package repo should you choose to. So I want to start how to use ports with how to use packages. It's easy, you just do a package update to download the catalog of the 30-something thousand. This is saying there's 31,770 packages downloaded there, as you can see. And then you can do a package search for your favorite package. And once you find the one you're looking for, you just do a package install, and it'll pull it down and install it really quickly. So that's how you should use packages. What about when I want to upgrade to the latest packages? Every few days they're rebuilt. Simple package upgrade command, and it'll pull down the latest one for you. So how do I configure repos and packages? Well, one thing people may not realize is FreeBSD out of the box comes with, it'll use the quarterly package repo, and essentially all daily ports development by the ports occurs in the head branch, which is still quite stable. You're not supposed to commit things to ports head unless it works and it's being tested. But there's a quarterly branch which is copied from head at the start of every quarter, and only security updates and bug fixes get backported from the head branch to the quarterly branch. So if you're the type of person that prefers things to be stable and you don't really want to be pulling down the new version of GNOME and Firefox every single day, because system administration is supposed to be a background task, not necessarily the way you use your computer daily, then quarterly is probably for you. If you're the type of person that wants cutting-edge packages, then you can get that too. You just use the latest branch. So one thing I sometimes find confusing is the difference in language. So in packages, the term latest correlates to the term head in ports.
Alyx?
And the term
Alyx,
quarterly
still there?
is a branch that'll look like branches /2020 Q1, for example. And so if you open up the file etc package freebsd.conf, you'll see some instructions in the comments at the top here, which is essentially saying if you want to disable this branch, then don't edit the etc package freebsd.conf file. Create a new file in user local etc package repos freebsd.conf and put enabled no there. And then you would obviously, if you're going to do that, you'd be creating another file saying, well, the package repo that I want to use is over there, and I'll show you how to do that a little bit later. You can see here that by default it's using the quarterly branch, and you would change that to latest if you wanted to use the latest branch. So here's a slide on that actually, and then once you've changed that line, you run package update and then to pull down the new catalog from the latest package repo, and package upgrade to apply the packages. Pretty straightforward. All right, so how to use ports if you must. Remember, I recommend probably not doing this. The first thing I'd say is read the FreeBSD handbook. There's a really good ports chapter that everything that I'm about to tell you is clearly documented there and gives a little bit more of a narrative as to why and how it works, etc. So step one is actually to install a package, which is a little bit, sorry about that, a little bit backwards. I'll just pick that up and fix it as I'm going. So the reason you have to install package first is because ports build packages, and so there's really a dependency if you're going to start using ports to build packages. Sorry, I've gone one step ahead there. So ports build packages, but you also need to be able to verify you've got a secure HTTPS connection to the ports tree that you're downloading. So you need to download some SSL root certificates that you're going to trust. And so you really need to install these two packages first. Once you've done that, you'll download the ports tree. And if you, during the FreeBSD install, you had an option to install a ports tree, if you did that, this is where you delete that, because that's baked and it's static at the time of a FreeBSD install, whereas probably what you want in your ports tree is something that you update almost on a daily basis to be the latest ports tree. So the first thing I would do is rm-rf user ports, and then the other little trick here is, unless you want to be building ports as root all the time, which I don't really recommend, then you want to make sure that a certain number of folders are owned by a user that's not the root user. Otherwise, you'll have to be root every time you're building ports. So come up with your favorite user that you're going to build ports with, and change 3 folders: user ports, vardb ports, and vardb portsnap to be owned by that user. So now I'm going to talk through 2 ways that you can download that ports tree. The first is portsnap. This is the fast method, and probably what a lot of users would want to do. But if you want to be contributing to ports, creating patches for ports, you really want to be using Subversion, which FreeBSD's version control system is Subversion. A lot of other open source communities have moved to Git. I quite like Subversion, actually. It works for me. But yeah, the original pull down of the ports tree using Subversion is a little bit slower by an order of magnitude. So be patient if you want to use that version. So using portsnap, type portsnap fetch, and it will download the ports tree. And then you type the command portsnap extract, and it will extract the ports tree into your user ports directory. Now I'll just point out a little bit of syntax here. You see how I've used a $sign on the left? That syntax means that you're not a root user. So you're not having to run this command as root. You're a non-privileged user. If you see instead of that a hash at the start of the line, that means you have to be root to run this command. And so whenever you want to update your ports tree, whether that's daily, weekly, up to you, you run portsnap fetch update, and it'll pull down the latest updates. I ran this command preparing these slides about 20 minutes later. I wasn't expecting there to be any updates, but as you can see, it pulled down seven patches in that 20 minutes. So portsnap is up to date quite regularly. So the slightly slower version, if you don't want to use portsnap, if you want to be able to generate ports and generate patches and contribute to ports, you would install. You could use devel subversion, which is where you can actually install subversion from ports, which is a little bit recursive and iterative. You need to use ports to. You have to download subversion from ports in order to use ports. But base does come with a command called svn lite. And you can do basically everything with that you need to. And so the command that you would use is svn checkout, and then point it to the upstream subversion repository, and then also where on your file system you'd like your ports to live, which is typically user ports. And it'll do that. I've got a little dot here. There's thousands of lines. It downloads all 38,000 ports, and it was at least half an hour. It takes a long time. But then whenever you want to update your ports tree, you just cd into your ports directory and run svn up, or svn lite up if you're using that version. Once you're doing updates, that's pretty quick. It's just the first pull down of the ports tree that takes a while. All right, so let's install our first port. I'm going to install Dialog for Ports, which is a program that actually helps you use the ports tree. If your program that you're trying to install has build time options, for example, do you want to turn on Samba functionality in this program or not? It'll pop up a blue dialog box, which we'll see later, and say, do you want this option or not? That is actually provided by a port called Dialog for Ports. So you would CD into user ports, ports management, Dialog for Ports, and then you'd do a make install clean, and it'll download the program, build the program, install the program, and then clean up after itself. Pretty easy. We're going to dive into a little bit more of what that's actually doing in a moment. That's just the rest of the build command there. And so let's install our second program now. Let's install the package tool again, and this time we'll do it from ports. And so we'll CD into user ports management PKG, and then we'll do a make install clean. And we're presented with this options dialog, which is what I was talking about before. The dialog for ports tool is the one that's providing this pop-up and options to select. So here you have the option to turn on, do you want to install the documentation with PKG or not? So you just hit spacebar to select that or not, and then you'd hit OK to move on. Once you do that, it downloads the program, and you can see ... There's a bunch of build output, and then it throws an error. And you can see that here. And what it's saying is that, hey, you've already got package installed. You did that earlier when you typed that PKG command. So why are you installing it again? So if you want to install the new version, you've actually got to run the make reinstall command, and that will essentially uninstall the old version and install the new version, and then that'll finish cleanly. So you want to find the ports for your computer. There's a nice website, freshports.com, like this. And let's say you're looking for the lsof command. You would just type that in the top, and you get two versions pop out. There's the main lsof. This is probably what you're looking for, and there's some Perl version or a Perl wrapper for lsof. So now you've found the name of the port you want to install is lsof there, and you can also see which branch it's in. It's in the which category it's in, the sysutils folder there. So you're going to want to go to cd/user ports sysutils lsof, and then do your make. But you haven't installed a web browser yet. You're on your computer and you don't have a browser. So you can do this as well. So you CD into user ports, you run a command make fetch index. It'll pull down the index of your entire ports tree. And then the command you can use is make search name equals lsof. And you get the basically the output that you just got from FreshPorts bit in a terminal. The nice thing about this as well is that it shows you what dependencies the programs have. So lsof doesn't depend on anything. So you've got bdeps, which are build time dependencies, and rdeps, runtime dependencies, whereas the Perl program here does have a few other dependencies. This slide took me a while to prepare, but it's one of my favorites. I hope you like it too. The individual make steps that are run by the ports framework. This is essentially, if you CD into a port and you just type make, that you're taking this stream on the right-hand side. So it's going to do all of these steps one by one, and eventually run a make package and stop there. So if you just type make, it actually doesn't install the port on your system. What has it done? Well, it's gone through the configure step, it's done a bit of a sanity check, it's downloaded the upstream source, it's done a checksum to make sure it's not corrupted, it's extracted it, patched it, run a configure, built it, installed it in a staging directory, and then made a package, and then stopped there. So you could choose to then do a package add of that package. That's how you could then go and install that on your machine. But if you run another step here, you can just run make install, and then it'll install that package for you. And then make clean cleans up the working directories that were used to perform all of these steps. And then you've got make deinstall and make reinstall. And then if you ever want to run this config step again, you can clear that back to default if you want by running make rmconfig. The nice thing about make as well is that you can string these together and it'll run them in order. So you can write make clean install clean for example. And so when you do a make clean, here it doesn't actually depend on all these other ones, so we'll run the clean steps. And then the next thing you said was install. All of these steps here, and then we install. And then the last command is Alright, so how do these things work? What is this port tree? It's really just files. So they're really nice with files. So they provide a standard macros, set of standard macros. For those who don't know what makefiles are, they're really instructions directly file link and install programs.
Alyx, you still there?
It consists of rules in the following format, and this is a generic makefile. This isn't ports makefiles. So the structure is you have a target, and for example, what a target means is make install. Well, install was your target. Make clean was your target. So you have your target, then a colon. You list any make dependencies. So if you're going to do a make install, well, that's going to rely that depends that you've done make package before, and make package depends that you've done a make stage, and make stage depends that you've done a make build. And so each of those has a dependency string up the chain. And then once you say what is it? Once we've satisfied all the dependencies, what does this target actually do? And it's just a bunch of commands there. So you could write echo hello in that line there, and that would mean that the make clean command would just print hello and not actually do anything useful. So as I was saying here, you just string your make and then targets together. So the ports framework, these are pretty make files. As far as make files go, these are whoppers. And so as I was saying before, the port framework does all the support, but the magic actually exists in this line here. And you'll see that line at the bottom of every single ports. Has that line. What does that do? How does it work? So each individual port, in addition to that, always define a set of variables. Those variables are things like, what is the name of this port? Where do I find the upstream files that I'm going to fetch? Is there any custom steps for they're just a bunch of variables inside ports. They might also override some of the make targets. So the way that you need to configure for this port is slightly different to others. So you might override some of these steps that are defined by the and then you .port.make. So when I was actually trying to work out how does that work, I realised I didn't know either, so I had to go do a little bit of research. And so I typed in the make page, and it turns out it explains in there that there's a default system include path, and that default system include path in there you'll find the bsd.port.make. Okay, hang on a minute. But that folder is part of the base. So how does that work? And so I opened up this file here, and really it just points you to your ports tree and says run the bsd.port.make file that lives in your ports tree right there. So it's just a wrapper, if you like, or a shim layer that points to your ports tree. So that's how that command works there, and so once it works out where your ports tree is, it then does include in there to include ports to make bsd.port.make, and that's the big one. That's the proper bsd.port.make. bsd.port.make is the main one, but it'll include a bunch of other make files that are part of the broader ports framework as and when it needs to. Depending on the variables that you've defined in your port. So for example, if you put users equals gnome, then that's going to include mk users gnome.make. So that's part of the broader ports framework. So the main subset of the ports make files is these ones here in user ports mk star, and what you can see on the left-hand side there is the number of lines of code in that file. And so you can see a lot of these here are pretty small, but the main one is I recommend opening that up and reading it. It starts with a whole bunch of comments. There's like hundreds of lines of comments at the start of the file that actually explain how it works. It's almost the best documentation of how ports work is in that file. So if you're interested, open it up and have a look. But then, as I was saying, there's a whole bunch of users files as well, and this is some of the examples there. So in the interest of time, I'm going to skip on. There's a bunch of ports categories, so any program should be able to be categorized into folders. There's also some virtual categories, so you can have, maybe Firefox is in one category, but also in the second. All physical categories will have a file that just defines all the subdirs. So if you're going to add a new port, you have to add it to this list here. Right, ports development, some examples. Step 1, read the Freebsd porters handbook. This is not the Freebsd handbook, it's a separate book called the Freebsd porters handbook. It's really long, but it's really good. I don't necessarily recommend reading from the top to bottom. It's more of a reference guide, so when you're trying to work out how to do something in ports, it's a really good guide on how to do it. So we're going to step through how to create a new port, and I'm going to create a text box like AHA port. This program, but I actually found it in the process of making these slides, and I made it a couple of days ago as a process of making these slides. I created this new port a few days ago. So first step, check the port doesn't exist. I've made this mistake a couple of times myself. I've committed a new port and found out, whoops, there's a there in that other category. I just miscategorized it. So you do a bit of a search around. Next step is make sure you make that index entry in the category makefile that I was talking about before. Then you've got to create the port skeleton, which essentially exists of a port's makefile, and I created this initial skeleton here, and it defines things like, well, where do you download this from? Well, it's GitHub, and the GitHub account is the Ziz, and then you have to define a maintainer, and this is a bit of, basically you're promising to maintain this port. Define a little bit about the license. The nice thing about this program is it has a dual license. It can be under the lesser GPL or the Mozilla public license, or either, which suits you. And then, of course, the magic include bsd.port.make at the bottom. There's another file called package description, and this, pretty clear what it does. It provides a long description of what the program does and a website. And then you need to define the size of the upstream package that is going to be downloaded and a checksum for it, so that all future people that download it can actually check that it wasn't corrupted during download. So you run this magic command called makesum, and it will download the port, the upstream, and then create the distinfo file for you. It'll run the checksum and save all the details in there, and you can see that here. It's created the distinfo file. You also need to, if you're going to create a new port, you better go read the build instructions that come with that upstream program to make sure that you're following what the original developers planned for how you would actually build that program. So you can do that now by doing a make extract. You'll have the source tree on your file there on your machine, and then you can just do a less of their README. And you can see here they provide a bit of an instruction. And this particular program doesn't even have a configure stage. You literally just run make. But this isn't a make in the ports tree, it's a make within their source tree. So our ports make is going to call their make, if that makes sense. Reviewing the upstream make file, this is what it looks like. Pretty standard, really. So it looks like it should just work, trademark. So now we run the portlint command, and essentially this is going to check that our new port matches a few rules that we can use, and so it prints out, looks fine. Okay, good. So I haven't made any obvious errors in my port to date. So I'll test the build. So you can see here I run a make clean stage, and in the process it spits out a build warning. This is just a difference between the way GCC and VM work, but it's only a warning, so I'm going to ignore that one. And then the build continues, and it spits out a new warning at the end here saying the bin aha command is not stripped. Essentially, with the ports framework, you're supposed to actually strip all binaries. So we're going to fix this. We add a new line to our ports make file, post install And if you want to know what the strip command does, within your port you can run make-V and then strip underscore command, and that'll show you what that variable actually is. So it's user bin strip. And if you want to know what that variable is, staged-dir, you can do the same, and lastly for prefix as well. So, and these are all depending on the variables defined in your port. So it's a nice way to sort of debug your port and see what these variables are going to expand to. You have to define in your port every single file that will be installed by this port, and that's called a package plist. But rather than do it yourself, you can run the command make plist, and it'll stage the port, find out all files that were installed, and create a plist for you. The only thing is, it does spit out this at the top of the plist, /u/have/to check what make plist gives you. And it's saying, don't just trust this, apply brain first. Also, given that there's only two files installed by this port, you really don't want to use a package plist file. Just define this in your make file. So you can, instead of having a package plist file, just add 2 lines in your make file that look like that. I'm going to do a bit of an iterative development process and run another portlint. What does it look like now? And portlint now spits out a few more warnings, or actually these are errors. It's saying, your package plist, you're not supposed to install man pages in share man. You're supposed to install them in man. And going back and looking, so we need our plist to change like that. So going back and looking at the original make file that comes with this program, I noticed that there's an option you can add to make called mandir. And so essentially within our port, we now need to add in our port make file, you add a make_args mandir equals man prefix /man, and that'll fix this to be installed in the correct place on the file. I've got 5 minutes left, so I'm going to start moving forward a little bit, but I need to get all these slides on the line. So now we run a make install again, and get that same build warning before, ignore that. And it finishes, it installs. That's great. So we've got a working port. We do a make deinstall and a make clean just to make sure that it tidies up after itself. And that's what the final make file looks like after you've added make args location. So this is now the final port make file. So if you want to develop, if you want to capture all this in a diff, you can use Subversion to do that if you created your ports tree with Subversion. So you just simply cd into your port folder, run a make clean to make sure you've tidied up, go up to the root of your ports tree and make sure you've done an svn add to add files that are in your new cd again to make sure it's the root, do an svn status, you can see, yep, these are the local changes that your port tree has that aren't in the import tree. And then you can run a svn diff command and that'll spit out a diff and you can save it to a file. But you're not a ports committer, so you can't commit that to the ports branch. So you have to do a bug report. It's not really a bug, it's more of a feature request. You're asking for a new port, but this is a new port with a patch attached. So you're not just saying, please someone go and do the effort. I've done the effort, here's the port. We love these as ports committers. These are all singing, all dancing bug reports. So then some ports committer comes along and we'll have to commit that to the ports tree. So essentially once we've downloaded your patch and applied it, we just run the svn commit and we make sure we're capturing both the category makefile changes and also your new port, and it'll commit it to the ports tree. So only ports committers can do this, but as I've got a little flag down the bottom here that if you are a source committer or a docs committer, you can also commit this, but you'll just need to get approval from a ports committer. When we create commit messages that explain what's happening, so the commit message says, you know, we're going to add a new port, give a bit of a description of what the port is, and then behold, your new port is available up to within a few days, we'll be able to install a hub. Given that I can see days ago, over my next one, which is how to update an existing port. The slides are available on YouTube. Pretty simple. How you can submit patches using Bug. What patches are we looking for? What needs work? Well, with 38,000 how can you find the ports? There's a link there, so feel free to click the link. Outdated ports, so ports where there's a new version available upstream. There's a great tool called Port Scout that automatically tries to find where what we've got in ports is out of date with what's upstream. Ports without a maintainer. So the original maintainer has given up, and maybe they've given many years of service, but they no longer want to maintain the FreeBSD port, and it's been reset to ports at freebsd.org as listed as the maintainer. That's code for no one's maintaining this. Every now and then a ports committer will come along and do their best, but if you feel like adopting a port, go nuts. And also submit new ports. If you're looking in the ports tree and you find that your favorite program isn't in there, then yeah, feel free to submit those new ports. I was going to talk a little bit about the process for becoming a ports committer, but I'm out of time. Suffice it to say that the original time I was proposed as a ports committer, it was denied. And essentially they said, look, come back in a few years when you've got a bit more experience. You don't just become a ports committer on day one. So I came back a year later and it was granted. And I was assigned 3 mentors, Adam, W, Cubes, and Matt. These are pretty powerful players in the ports community, so I was lucky with my mentors. And so I just want to give a bit of a shout out to my mentors that helped me become a ports committer. Those guys are legends. And lastly, I was going to talk a bit about Poudriere, but I'll have to skip over it. You can see it's got a nice web interface to show you what it's doing. It essentially allows you to bulk build ports in parallel. I've heard people say that it's hard to set up Poudriere. That's every command you need to type to set up Poudriere, so it's really not that hard. It has some nice console output as well, and it's colorized to show you what it's doing as it's bulk building ports. And if you want to have that web interface, that's how you have your nginx config, and that's how you point your local machines, the package command on all your other machines. If you want to use your new fancy package repo that you've created with Poudriere, that's how you do it. So, what are you waiting for? I'm here all week if you want to come up and grab me and ask me, hey, how do I get involved in ports? I'll be more than willing to talk you through that. And that's everything I had. Any questions? Elongated clap at the back there. So it is lunch, so don't feel like you're holding people back from lunch. We've got time for a couple of questions.
A few projects around using free and open source software for film, and I alluded to the fact that this is hardly the only project by artists who are using free and open source software, and I just wanted to briefly mention a few other people who are doing that sort of thing, because I think it's good to kind of find these people and support them, because first of all, to encourage other artists to do it, to take the plunge and use free and open source tools, but also because often these artists are actually extending the capability of the tools, because in their art they know what features they need, and even if they themselves are not software developers, some of them are, but the ones who are not are still working with the software development community to actually go, look, I need this feature, I need this, and why, and how is this useful in my art? So it's really driving, I think, innovation in a direction that makes it useful to other artists. So this is just a short list of some of the examples of things that I've found. A lot of these artists do have Patreon pages, so you can financially support them if you want to, which is also quite useful. So one of the most active is David Repos.com. He's very active with Krita. He has a webcomic called Pepper and Carrot, which he's made available so people have been doing things like dubbing it and even animating it now. So people doing animated versions of his comics. But he's been very active in encouraging the Krita people to add features, and has been using exclusively open source software for his art for a long time. I think he blogs about it as well. He's very